Hi, in the last few sessions, we have covered VSGL signals and data types. We talked about enumerated data types and also pre-supported data types in VSGL. Till now, we have covered std logic vector, integer, boolean data types, as well as enumerated and array data types. Let's quickly recall the data types which are predefined in VSGL standard package definitions, and we will also see std logic, stdu logic inside the std underscore logic underscore 1164 package. So first we are talking about VSGL standard definitions. Okay, so first is bit data type, which has two values 0 and 1. Hence you can see it like type bit is 0, comma 1 semicolon. Second is Boolean. So suppose you wanted to create similar by your own. So you can write that type Boolean is false, comma true, semicolon. Next data type is character. So write type character is then all the sky character inside this semicolon. I didn't mention individual values or iterations here because ASCII has 255 characters. But if you are defining this data type, then you need to copy all the ASCII characters in this area. Another is severity label, which is generally used for the test functions to specify some warnings or note or error or failure kind of stuff. So write type severity label is then note, comma warning, comma error, comma failure, semicolon. Now just quickly see std logic and stdu logic data type, which are defined inside the std underscore logic underscore 1164 package. So you will see that type std underscore u logic is then u, comma x, comma 0, comma when, comma z, comma w, then l, comma h, comma dash, semicolon. Note that all the values are written inside the single quotes. We already talked about these states and enumeration in our previous videos. We also talked about std logic, which gonna be widely used in our designs. Do not confuse with the std underscore u logic and std underscore logic data type. I mentioned std underscore u logic here because std logic is just a subtype of std underscore u logic and hence having the same values. I prefer to use std underscore logic widely in our designs. VSGL subtypes are the subsets of the base data types. Additionally, you can declare subtypes in VSGL. So subtypes are usually a subset of the master data type, and that allows you to define more specific constraint of the values. And this can help make your code more readable and maintainable by providing more precise control over the data types you use. Let's understand this with some examples. So in the standard package, you will find natural subtype, which is defined as a subtype of integer data type. And the range of natural data type goes from 0 to the highest value of the integer type, which is 2 to the power 31 minus 1. The high attribute returns the highest value. So how you will declare this if you wanted the similar data type? So write subtype natural is integer range 0 to integer dash high semicolon. Similarly, you can create something like subtype positive is integer range 1 to integer high semicolon. Or even you can specify any range based on your project requirement. So now we know that how to create custom data types and sub data types. And even now we know that how predefined data types and sub data types are defined in the VSDL packages. Now we will see that how we will use them in the VSDL code. So suppose we are declaring some signals in VSDL with subtype natural and positive subtype. So how we will write them? Well, they are exactly same. Like we declared the signals earlier. Even the syntax is exactly same. So write signal sig underscore natural colon natural semicolon. Next is signal sig underscore positive colon positive semicolon. You can use any signal name by your wish. Just remember the rule of identifiers. The only difference between the natural subtype values and the positive subtype values is that the natural values includes all the positive numbers up to 2 to the power 31 minus 1, including 0 value. But positive subtype does not include 0. That's it. So by now we have seen that how the predefined subdata types declared in VSDL packages and how they were defined inside the packages. Now just quickly see that how we can create our own custom subdata type and how they can be good choice for our designs. Let's understand this with some examples. So first user defined subdata type which I have written is address underscore line. This is integer and required to address 256 elements. So I have written subtype address line is integer range 0 to 255 semicolon. Another example is defining byte subdata type, which have 8 bits inside it. So write subtype my byte is std underscore logic underscore vector 7 down to 0 semicolon. Now we will use these subdata types to declare our signals, which you can see at the bottom. So signal sig underscore address colon address line semicolon. Another example signal sig underscore data colon my byte semicolon. Now you do not need to worry about your 8-bit data length and defining std underscore logic underscore vector. Just use my byte straight for 8-bit data. You can also use individual element of this data. Like if you wanted to use MSB or 7th index of your byte, then just use signal with the index ID inside the bracket. This is as simple as that. This is super cool, right? So try to prefer to use your own data types and sub data types in your projects and deliveries. They will make your VSGL codes more readable and easier to use for future. These codes are more impactful and customizable for future as well. Also, your chances of error will definitely reduce if you prefer to use these good practices because you will encounter errors early, like something out of range values, etc. In the next session, we are going to learn more on the array data types, custom data types and their use cases. And I will tell you that how you can use these VSGL concept in your practical designs. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video and don't forget to share. Thank you for watching.